Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Moon to Earth Sling to Mars video series that I'm doing. And this is not going to be a complete mission. We're just doing the explanation on how to set up this flight so that if you want to do this flight, you can. And I've already got another example of this, a good example in my opinion, where I went from the Moon, did an Earth Sling out to Venus. So that's another example that you can refer to. I do have one other example where I think I did it in the XR5, where I started off on the Moon, then did the Earth Sling and went off to Mars. But that was the very first time I did it, and that explanation was kind of lacking, so I don't really count that one. So I wanted to do at least one more example after I did the Venus one, so that we'd have at least a couple of examples to go by. So this is the third part in this one. So if you haven't seen the first two videos, make sure that you watch those first, because otherwise none of this is going to make any sense. Let's go ahead and jump back in here. When we left off, we had just reached our our cutoff point at the Moon. We got our apoapsis of 20 kilometers, and we're saying that we're going to reach apoapsis here, and we're going to reach the eject point there, and it's almost the same. So we're not going to have to worry about orbit circularization. We're just going to set up the maneuver and take care of that. All right, let's go ahead and go back to real time, and let's bring up transx. Let me think about this. What are we doing? Bring up transx over here, and we want to go back to stage 1. And we're going to, again, I don't like that type of view, so I'm going to go to view setup and change the graph projection just to something that looks better, like focus. That's good. Or, let's go focus. And we don't really need to set up the maneuver until we're within about 1,000 seconds of the time to begin the burn. The first few times you do this, you may want to give yourself a little bit more time than that. But if we set up the maneuver too soon, let's say we're 2 or 3 or 4,000 seconds away from the time to begin the burn, then we're going to have to just refine it as we get closer anyway. So I think 1,000 seconds is enough time for me, hopefully. So I'm going to warp time forward till I'm 1,000 seconds out. And there we are. That's good enough. Now we're going to set up a maneuver on transx instance 1. It's important to understand that this is instance 2 of transx, and we're setting up the maneuver on instance 1. So we're going to come over to view maneuver, turn maneuver mode on, and go through the variables until we get to prograde. And we want to put in this amount of prograde, this 842.4, so we can just press enter and type in that number, 842.4. And for the timing, we don't have the case where we can just put in that number of time, 9:33. So what we actually have to do here is press VW to get over to target, and then we'll press VAR until we get around to the eject date. Should have went backwards. There we are. And we're going to add in enough time on this eject date until it matches the begin burn time that we see here and here. And the way you want to do that, you don't want to do it on course. Go backwards to, say, ultra. And now just put in clicks like that. You can see the begin burn time going up. And I want to match that number as closely as I can. It does not have to be perfect, because we're going to make changes to the time anyway. But try to get it reasonably close. It's reasonably close now. Let's go back just a little bit. That was too much. Let's get down to micro. And now they're more or less in sync. It's not perfect, but again, it doesn't have to be. Okay, now let's press VW to get over to the setup here. Escape plans. All right, now just bear with me. Again, this isn't something I do every day, so it takes me a moment to remember all the steps. We're done with transx stage 2. We don't, or transx instance 2. We don't need that anymore. So it actually could help if we bring up transx on this side. We're going to go back over here so we can view the maneuver. And we need to make adjustments to the maneuver, small adjustments to the maneuver, so that we have two things happen. The first thing that we need to have happen is we want our focus PED to match the focus PED that we have specified here, which is 6.571. Currently, the focus PED says that we're going to get back to Earth, and we're going to have an altitude that's like, what is that? It's over 1,000 kilometers, like 1,400 kilometers. And we need to bring our relative inclination down. We want to start by adjusting the date variable. So just by going forward or backward, and that's why it doesn't matter if you get that date matched perfectly or the begin burn time matched perfectly, because we're now changing it anyway. So I can see that by adding in some date, it's bringing down the focus PED, and it was bringing the relative inclination down there for a bit. Let me actually do this also. Let's change over to the eject orientation. And let's adjust this line so that it's over here, our current position, so that we have a more accurate relative inclination. And then let's kind of back it up a little bit and find the lowest point. Just back here somewhere. Okay, so that gives us an idea. So we definitely need the relative inclination to come down. All right, so again, just adding in some date. Now it looks like the focus PD is actually starting to go up. Okay, so right there is the lowest. Now I'm going to switch over to prograde. Guess it'd be better to go backwards. Yeah, okay, so var like that, we'll do it that way. So just var forward to go to the date, minus VR to go to prograde. And we'll go down to probably a super setting and see what that does. Now adding in a little bit more prograde. You can see it's not a huge amount. We're just adding in, decimal points at a time. But it's having the desired impact. It's bringing the focus PED down, and it's bringing the relative inclination down. So we're going to bring the focus PED all the way down to what we want, which is 6.571. But we need to kind of overshoot it a bit because the relative inclination needs to come down also. So I'm going to go all the way down to like 6,100, about right there. Now var forward to the date. Now we're going to see, okay, now we're going to take out some date. And that's bringing up the focus PED, and it's bringing down the relative inclination. And that's what you have to do. There's a little, back and forth trickery. And then we'll, again, swing that line around. We don't want it to be too far off. Okay, that's as much forward as we're going to get there. So let's go back to the prograde. And let's take out some prograde. That's raising the relative inclination, but it's bringing the focus PED up. So I might need to overshoot in this direction. Let's try that. Let's go to 6, 7. Now back to the date. And also update every now and then is always a good idea. Now as I take out date, it's bringing up the focus PED, bringing down the relative inclination. Okay, back to prograde. Okay, we're getting close to our desired numbers here. Let's go down to adjustment of ultra. We're 6.577, so we're really close to 6.571. Let's do a little bit more adjustment on the date. Okay, let's swing that line around a bit. And back to prograde. Okay, that's a bit much. Now that we're getting really close, we want to be careful that we don't do too much adjusting at one time. So we've got the focus PED where we want, but we really want to bring that down a bit more. It's still not quite what we want. All the way out here at the moon, we're saying we're off by 0.7, but as we get closer to the Earth, it's coming down. But it's really not low enough. We really want to have it be like 0.1 or less by the time we get, let's say halfway. So let's just continue to adjust a little bit more. So by adding in a little bit more prograde, we're bringing down the focus PED and bringing down the relative inclination. So let's do that a little bit. Let's come down to say 6471. Now we'll see what happens with the date. Okay, that's going the wrong way with both of them, so we can bring the date back. Do a bit of an, let's not go to reset, that would suck. Okay, so now we've got a very low relative inclination, but we need to work on the focus PED now. Oops, that's the wrong way, 6571. Okay, we're at 548. That's fine because I want to have a little bit of room to play with on the date. Do an update and see what we can do with the date here. Yeah, taking out a little bit of date is helping bring down the relative inclination and it's bringing up the focus PED. So I'd say we're just about where we need to be. Yeah, you can see it's getting very sensitive. The line of nodes is getting very sensitive at this point. So we're less than 0.1. So it's fine right here. But let's get the focus PED set exactly where it needs to be. So let's go to prograde and go all the way down to micro. That's a bit too much. 6.571 is what we want, and relative inclination is good enough. You don't really have to play with it, beyond this point, because as we go forward through our trip from the Earth down to from the Moon down to the Earth, it's going to change a little bit. But we want to start off, with a low number, and it's actually it looks like it's trending up. So I would actually rather have it be the other way around. So what I'm going to do, and I don't know that this is even necessary, but I'm going to overshoot it the other direction so that it's trending down. But let's check our time. We've still got like 6 minutes or something. Okay, so let's go to the date here. And just by taking out just a touch of date this way, let's not do quite that much. But I think at this point we've kind of overshot, and now the relative inclination will go the other direction. Just get this set right. It's still going up, but it's very low, so we're not going to worry about it. But I will get that focus PED set back where it needs to be. Oops, that's a bit much. Right there's what we want. Okay, so we can do this burn. Let's view over to target over here. And let's help out the auto center autopilot by getting our vessel into the prograde position now. That way the auto center has less work to do. And we'll find the auto center variable here. I always do an update every time I go across that. And once we get settled here in prograde, we'll go forward to begin the burn. Turn prograde off. And when I get to maybe 60 seconds out, I'll turn on auto center. About right now. And let me just quickly check my orbit to see where I'm at. Yeah, I'm not quite at apoapsis yet, so we are going to do the burn before we reach apoapsis. It wouldn't technically matter if we were just a little bit past it, but if you get too far past apoapsis, then you're on your way down, and you don't really want that. But we're fine in this case. Also, actually, almost completely forgot. We want to bring up interplanetary MFD and bring up the map program, and we want to reference Earth. And we want to turn auto zoom off, display on. Actually, let me go down to 0.1 for a second. Make sure that we have reference Earth, and we want to make sure, actually we want to page over, not page, but select, so that we have the PE settings instead of the AP settings, because we want to make sure that our PEA at Earth is 200 kilometers exactly, because we can't rely on transects. It's too inaccurate. So let's get ready to do the burn here. Warp time forward just a little bit. Get burning in 3, 2, 1. Blast off. Do a little bit of time warp. Not much, because it's a very short burn, relatively speaking. And we're going to watch over here, and we're going to use this as our indicator for when to stop the burn. Stop the burn now, and then now I'm going to continue with the burn just on a little bit of a, control plus until the PEA is 200. A little bit more, and just a little bit of translation to get it right there at about 200. Now, very important, turn auto center off. And the reason, again, that we use this as our indicator, because you'll note that according to transects, we still have 9, almost 10 delta V to go. And if we did that, then our PEA would obviously be probably below the surface by quite a bit. So it's important to use that as your guide and not transects. Okay, now we can turn maneuver mode off. So VW over here. Maneuver mode's off. Kill rotation so that we're not spinning wildly around as we warp time forward. Now we just want to warp time forward until we're pretty far along in our journey. Bring up the escape plan view over here. And just bear with me for a moment, I'm adjusting this till it's accurate. Okay, now once you have completed the ejection burn for going back to Earth, the only thing to do is warp time forward, so let's do that. Let's get out away from the moon. And what I like to do is warp time forward until the velocity, or until the HUDs kind of come around to that negative position. See here in a moment when it's 180. Warp time forward at 1,000. And then once it's at the negative, I'll come back to real time just for a moment and kill rotate. Then we can warp time forward at like 10,000, get out quickly. Now we're orbiting the sun. And a couple things I'm watching, how far along in the journey I am, and I'm watching the relative inclination. Notice it's trending down. Actually, now it's going up. So let me check orbit MFD real quick just to kind of see how far along we are. Let's reference the Earth. Let's get in. We can go all the way until we're within Earth's gravitational influence when it's the strong SOI, even though that's going up. But we'll just get within the strong SOI of Earth anyway. Okay, there we are. Now we've got more data to work with over here. Now, before we go any farther along, we want to check our relative inclination. Let's bring interplanetary back up just to kind of make sure our PEA is not changing, and it's not. Now, first order of business, swing that white line around till it's over your current position. That's the wrong way. Okay, it's over the current position, so I know that number is accurate. Now I'm just going to put in some 10x time warp, maybe even 100, just to see what that's doing. Is it going up or down? It's going up. So I definitely want to do some adjustment now, because the longer I wait to do an adjustment, it's just going to continue to increase. If it were trending down, I would say just go forward. But since it's going up, we'll do an adjustment now. All you need to do is you need to be level with this line. So technically, if we just rotate here, that's good enough. Although I tend to prefer to be in the prograde position, but for adjusting relative inclination, you just need to make sure that you are, level with regards to that line, or you could even be like that, but then you would just use up-down forward-backward translation. But in this case, we'll use up-down. Now, the filled-in bubble is over here. So if it is filled in, it's normal minus. So we need to be thrusting, and we're upside down. So let me get right side up. Of course, you can always just use the up-down translation to see what happens, but I prefer to know if it is filled in, it's normal minus, I think. So we need to use 8. Oops, that's the I forgot to switch to translation. Yeah, 8. So we'll translate down to bring the relative inclination down. And since it's trending up, we're actually going to go all the way to 0 and then overshoot a little bit. And I don't really know by how much, so we'll just go to that number. Now I'm going to warp time forward until I cut the PET in half, so we're at about 130 right now, so we'll go to 65. Make kill rotate. When the PET is 65K, we will check things out again. You can see that's trending down. And we can basically skip it. Skip any corrections that we would do here otherwise. Well, let's actually, before we determine that for sure, let's get this lined up exactly. Yeah, it's still going down. So let's cut this in half again. So let's go down to 30. About right there. Now let's check everything out. So we're at 0.1, and it doesn't seem to be going down too quickly. So let's go ahead and do a bit of an adjustment here. Let's get level. And this time we're going to be using 2 because that bubble is not filled in. Let's go to 0.5, maybe 0.4. Now let's go forward until PET is 10,000. Okay, so we're 10,000, almost 11,000 seconds away, and relative inclination is not coming down real fast. We're getting in so close, though, now that it's kind of hard to lay that white line over top of the green line. So what I like to do here is to view over to the setup and change the scale to view to target. Now we can view back over to the escape plan, and we can see much more clearly where that white line is at in regards to the green line. So let's swing that around, do an adjustment down to ultra, and it's saying that we're 0.3. So let's bring it down a little bit more. Maybe like that. Now let's go forward until PET is like 1,500 seconds. About right here. And let's bring our line around. Okay, now the relative inclination is going up.
Rotation, translation.
So let's bring that down. And what we want to do, bring it all the way to 0 and then go around. And what we would like to do here is we would like to match this number counting down so that it matches closely to the time to begin the burn. So you can see that this number here, the third one, 1, 2, 3, that's counting down about 1 second at a time, we would say. So that means that's 380 seconds, and we're not going to reach the burn for 1,400 seconds. So if we set this to 1 and then that to 4, we should match that pretty closely. So something about like that. So that should be about 1,330 seconds. So by the time we get over to here, our relative inclination in theory will be 0.0000 across the board because we're really close to that number. In fact, we probably go a little bit more. Yeah, I don't worry about matching them exactly because this doesn't count down exactly 1 second at a time, but get it pretty close. Okay, so that is it for the trip from the moon back to the Earth. Now we have the all-important step of setting up the actual IMFD maneuver for slinging ourselves off out toward Mars. And I'm going to save that for the next video, even though we're only getting about 25 minutes each out of these. But I don't want to start an important step and then have to stop it a couple minutes later. So we'll go ahead and end this part of the video here. And when we pick back up, we'll complete the ejection for going out to Mars. And then that will be another example of how to do this type of flight. If you like this video, like it. If you didn't like it, don't like it. And subscribe to the channel if you're not already subscribed. Look for links in the description down below. I've got an FAQ, got a Facebook page, got some other stuff down there. And I will see you in the next video. I don't really count that one. So I wanted to do at least one more example after I did the Venus one, so that we'd have at least a couple of examples to go by. So this is the third part in this one. So if you haven't seen the first two videos, make sure that you watch those first, because otherwise none of this is going to make any sense. Let's go ahead and jump back in here. When we left off, we had just reached our our cutoff point at the moon. We got our apoapsis of 20 kilometers, and we're saying that we're going to reach apoapsis here, and we're going to reach the eject point there, and it's almost the same. So we're not going to have to work until we're within about 1,000 seconds of the time to begin the burn. The first few times you do this, you may want to give yourself a little bit more time than that. But if we set up the maneuver too soon, let's say we're 2 or 3 or 4,000 seconds away from the time to begin the burn, then we're going to have to just refine it as we get closer anyway. So I think 1,000 seconds is enough time for me, hopefully. So I'm going to warp time forward till I'm 1,000 seconds out. And there we are. That's good enough. Now we're going to set up a maneuver on TransX instance 1. It's important to understand that we're worried about orbit circularization. We're just going to set up the maneuver and take care of that. All right, let's go ahead and go back to real time. And let's bring up TransX. Let me think about this. What are we doing? Bring up TransX over here. And we want to go back to stage 1. And we're going to, again, I don't like that type of view, so I'm going to go to view setup and change the graph projection just to something that looks better, like focus. That's good. Or, let's go focus. And we don't really need to set up the maneuver. Okay, welcome to another Orbiter 2010 video. And this video is going to be a continuation in the Moon to Earth Sling to Mars video series that I'm doing. And this is not going to be a complete mission. We're just doing the explanation on how to set up this flight so that if you want to do this flight, you can. And I've already got another example of this, a good example in my opinion, where I went from the Moon, did an Earth Sling out to Venus. So that's another example that you can refer to. I do have one other example where I think I did it in the XR5, where I started off on the Moon, then did the Earth Sling and went off to Mars. But that was the very first time I did it, and that explanation was kind of lacking. So this is instance 2 of TransX, and we're setting up the maneuver on instance 1. So we're going to come over to view maneuver, turn maneuver mode on, and go through the variables until we get to prograde. And we want to put in this amount of prograde, this 842.4, so we can just press enter and type in that number, 842.4. And for the timing, we don't have the case where we can just put in that number of time, 9:33. So what we actually have to do here is press VW to get over to target.